Started. Welcome to today's virtual data workshop, Introduction to HPC and Slurm. So just a couple of housekeeping things before we get started. All of you should be muted and have your cameras turned off. We ask that you keep those that way while you're not speaking. We have a couple of ways for you to interact with us today and ask questions. You can either use the chat feature to ask your question, and somebody will be on chat to answer your question, or you can use the raise your hand feature. With that, I will turn it over to our speaker for today, Paul Vandermark from the Research Computing Center. Paul, take it away.
Thank you, Nick. So I've given similar presentations several times, but I've never really done this online. So this is going to be a new thing for me too. I thought I'm going to be very fancy, use OBS and virtual cameras, and then in the end it didn't work because I was logged into the wrong laptop. Anyway, so this is going to be just a regular presentation. Casey McLaughlin will be here. I think Terry might join us. He's our Slurm administrator. Just raise your hand if you have questions. And so let's start. So I always like to kind of start with what is HPC? Well, most people kind of know what HPC is about, but in general, it means that you need to aggregate computing power to just solve your problem because it's just too large to fit on a regular desktop or workstation. So that's very subjective, but this is kind of more or less the definition of HPC. And aggregate computing power, that can mean like a large giant cray, but it can also mean a large cluster of machines. And so what does it in general HPC job mean? So in most of the cases, what our users do, they have a program, they have some data set, it's just kind of regular science. And then they kind of run that on a bunch of machines. And it can be 1, it can be 10, it can be 1,000. Or if you have a large computing set, it can be 100,000. And in the end, you hope to get an output. I mean, it's just a tool. It's a computer. You just see it as a tool. So how does it look like? So what does a cluster look like? What does it really mean? So I just build it as building blocks. We have around 800 nodes. It's just large. Some of these numbers are not entirely accurate anymore. But it's like between 2 or 4 processors, and each processor is something like between 8 or 48 cores. It can be Intel, it can be AMD. I think we retired all the machines with 16 gigabytes, but we have between 16 and 256 RAM. And they're all connected with a 56 gigabit network. Our core is more it's more like an 80 and 100 gigabit, but our compute nodes are all connected with 56. If you compare it with your home network, where you probably have 100 megabit if you're lucky, or a gig if you have fiber. So it's a pretty fast network. Now, you have all these resources and you have so many users. So how do you kind of allocate all these resources to these users? I mean, everyone wants to use as much as possible and as fast as possible and as soon as possible. But I mean, how do you really handle that? So what is our system? Our system is a batch system. In essence, it's a batch system. We have interactive, but it's the same principle. So it's just like, imagine you order from Amazon and your job is a little package. So most of these packages or jobs, they're on a large queue and they're all being pushed out towards trucks that haul them all over to the country. And that's how you should see as our cluster too. So you have your jobs and are being scheduled by a job scheduler, and in the end, they run somewhere. You hope that they will run sooner than later. Now, there's also, we have an RCC prime, aka you can buy in, and that's this little small package here. And someone says, I want to run faster. So I said, here is my $5,000 grant, please give me my note, I want to run faster. So there's 2 types of jobs on our systems. We have the low partition, kind of the low partition jobs that you just push into the system, and sometime between 5 minutes and 5 hours they might run, or you have jobs that almost immediately start. So I show this picture of these resources. So how does partitions work out? So if someone in the physics lab says, I want to buy 16 of these nodes, we just divide up all our space into these green blocks, and you get, these are his nodes. The green blocks are his nodes. I don't think I have a pointer. So the professor in physics gets this, and the professor in the College of Business gets the yellow ones, and everything else is open for everyone else. So that's how you should see partition. A partition is a collection of nodes. You might sometimes see the word queue in this presentation. That's because we've changed catalyst, but Slurm uses the word partition. So I'm trying to use partition. So a partition is a collection of nodes that is either free for everyone or it's owned by a group that bought into it. And so how do you submit a job to that? I mean, it's Linux, so there's 50,000 ways, but the most common is either just through the command line, this is what most users use, or through a web interface. I will not go into the web interface that deep. Most of it is for the command line. That's a very simple reason, because it's always good to know the background behind it, what a Slurm job looks like. So the command line, since we're all off campus, you have to use a VPN. FSU uses the AnyConnect Cisco VPN. So if you're off campus, you have to connect to our resources through the VPN. If you're on campus, you can just connect, but I assume that most of us are off campus. Then you can use SSH to log into one of our login nodes. It's a small little bunch of machines, and it's just one name, HPC login. And from there, you can just type srun or sbatch, and you have a job file. We have a few more options. We have a program called OnDemand, and we have a script generator. The script generator will slowly disappear and will be merged into OnDemand, but I thought I mentioned it anyway. So OnDemand, the script generator is just it's just an interactive website where you can click and point and you'll get a job submission script. It's just very simple. It has some very limited syntax checking, and we have some templates available for some software, so it kind of create a job file. It does not submit any jobs directly for now, but in the future you might submit jobs by just clicking. So how does it look? Okay, I'm not going to give a crash. So it's basically a form where you fill out the program name, the partitions you want to run into, and it will create a job script for you. So we also have something new that's called OnDemand. OnDemand is like a virtual desktop, or you can just run a simple program. And what it allows you to do is kind of submit jobs through a web interface. And if they're interactive, you can attach the console on your browser to the running job. For example, if you want to run interactive MATLAB on one of the compute nodes, you submit a MATLAB job, you attach to that job, and you can interact directly with MATLAB on that compute node. For example, if you have a program that needs a GPU, you can submit a job to the GPU cluster. You can attach to it, and you can run directly as if you're sitting behind the console of that GPU node. Now, I'm not going to say a lot about it because we have a workshop about it next Thursday. And if anyone here is interested in kind of exploring kind of a virtual desktop, how to run interactive jobs on a cluster, I would really advise everyone to kind of tune in to the same channel on Thursday, September 17th, at the same time from 3 to 4:30. I think, Casey, that's the right date, right? I see Casey blinking.
Yes, that is the correct date, but I should add that you need to register for the workshop first, and you can do that on our website, rcc.fsu.edu.
So this is a very quick snapshot of the web interface. To the URL, you can see it's ood.rcc.fsu.edu. It's only available through the VPN, so you have to connect to the VPN before you can log into this. Log in with your RCC credentials. And in this case, there's a few items here. You can just start a desktop, or you can start MATLAB or Stata or Visit. There's Jupyter Notebook and RStudio. But more tools will be added in the future. But like I said, next week there's a much bigger demonstration about this, so I'm not gonna touch any of that. So the script generator demo, I should have moved this. So this is how our script generator looks like. It's just a form. This is a website. You fill in your name for the program, what to call. If you want to get an email notification, it's what kind of partition you want, how many cores, number of nodes, and automatically generates this field. And you copy and paste that into a job file on the cluster. For the future, I think this will be integrated with the Open OnDemand, and you can automatically run this from Open OnDemand. So you just click around here, you fill in the name, and you just say submit, and it will run. The nice thing is that you can also do things like module loads, this is a very old screenshot, but. So how does a job file look like? So we're going, and the coming slides, I'm going to kind of walk through the anatomy of a job script. So the job script is really the bones of how you submit jobs to the HPC. Like I said, we're using Slurm, and you can see that in some of the things. So this is job script. There's three pieces to it. First of all, it's a script, and it's not really a script. So like Linux, every script starts with this one line that kind of indicates what needs to interpret the script. Now this is usually when you have a script like this, you execute it, and this batch gets immediately involved, but this is Slurm. Now there's a second part here, which is instructions for Slurm. You can tell Slurm already what is the job name, how many cores do you want, do you want to have the output, do you want to have events sent to mail, do you want to name the output files different. So there's a second section here where you can get command. If you look in the manual page of sbatch, you'll see all those commands. All those commands can be used in this section. So in this case, you want to call the job, the capital J is my job name, -n is the number of cores you want to use. If you want to run on a specific number of nodes, not cores but nodes, you can have capital N, etc., etc. So this instructs Slurm how you want to run your job. And then there's the what you want to run. So this is kind of the bash script, and it says module load GNU OpenMPI. That means this is going to be executed on one of the compute nodes. It says, well, load this module. I want to use GNU and I want to use OpenMPI. PWD is just for your own reference that you can see where it's running. And srun starts a parallel program. It starts a program, my program. Srun is part of Slurm, so you don't have to, so it will start the my program on 10 cores that were allocated to you. So this is more or less the meat and bones of a job script. In this case, it's parallel. I will show you a sequential, but there's not much difference. In the past, I always did an interactive session, and I have not done that because I think that will be more confusing. But if anyone wants to see examples, I can always show examples. Just shout out, raise your hand, and we can start something. It's now this says bash. Can it be anything else? Yes. You can use Python, you can use Perl, but you can make it yourself very difficult. I always like to show an example with Python. The job submit is created in Python, as long as the language accepts the hash sign as a comment, because it should not interpret this. And one other interesting thing is, Slurm, if there's any text between this, you can have spaces, but if there's any text between the bash and the first sbatch thing, the Slurm will stop reading it. Slurm will only read up to the first text. And so now a sequential program, you see it's almost the same. It's the same schedule. There's the bash section. There is the instructions for Slurm, except I don't have a -n. I don't allocate any cores. The default is 1. And here I have my little section of what to execute. In this case, I'm using the program R. And I need to get R in my path, so I use module load R, and then I use R no save. Now the interesting thing is I don't use any input for R, because I specify that Slurm should pick up my R input file as the standard input. What this does, it gives the input, the text in my input, R input, as the standard in for R. So these are Slurm directives, and so is this a little clear? Because I might be going a little bit too fast and I don't see any feedback. So stop me at any point if things are unclear. And I don't see the chat because I do this screen. So Casey, stop me if you have questions, okay? So
hello. I just want to say that there are 2 questions on the chat right now. I know you said you couldn't see the chat.
No, I cannot see the chat.
Okay. You want me to read them off for you?
Yeah, sure. Go ahead.
Okay. There's one question, one comment saying, "I'm hopeful that you will show examples." And then the second question is, if modules have been loaded in the compute node, does one need to specify them in the script again?
Okay, let's start with the second one. If Slurm will copy your environment variables of the time that you submit a job. So if you have a variable set like the path and then you submit a job, Slurm will copy that variable. So in theory, you don't have to load the module. So example, this case, I do module load R. I could have just left that out. I could have done module load R and then submitted this script. Now, the reason why I want to keep it in there is just because sometimes I just want to just log in and submit a script and I didn't load the module. It's if you submit a script and you come back the next day and the only error you see is R not found, then you're like, you wasted your whole evening. So do you have to load the models in your job script? Most likely not, but just to be safe that you have everything in your path, I would do it anyway. Examples, I can load a terminal and show some examples at the end. Yes. So the big question always is, what partition you want to submit to? Because there's a plethora of partitions, we have several of them. So we have the quick test. The quick test is really just to check if your script is correct. If you're not sure, if you have very complex constructions, if you have for loops in your script, if you're doing whatever testing, processing, if you run multiple programs, if you run a shared MPI space, and you're not sure if your script is correct, you can use the quick test partition. Quick test is really just, I really want to quickly test this program. It's nothing for production. There's a wall time of 10 minutes. So anything over that, and it's also very small. So I think it has like 16 cores in there. If you really want to quickly test your script, then you can use quick test. If your program is rather short, we have the backfill and the backfill 2. Backfill and backfill 2 run on the whole cluster. They're everywhere. And so there's the largest resource. And if you can split up your job in small parts that run in less than 4 hours, the backfill or the backfill 2 is your friend. If you do the command sq so you can see where everyone is running, you would see that certain users really use that feature and run in backfill and backfill 2. The reason is because it's everywhere. The chance that that job will almost immediately start is pretty high. Now there's one downside, especially for backfill 2. Backfill 2 runs on our owner nodes, and owners one have priority. So a backfill 2 job can be preempted. So it can happen that your job gets killed after 2 or 3 hours. Now, if you don't really care about that, if you can do checkpointing, then backfill 2 is perfect. If you really need your job to finish in 4 hours, you need the backfill, the regular backfill. But still, because it's so large, that's a very popular partition if your job runs in less than 4 hours. Then there's two other more free resources. There's the Condor and the general access. Both of them have, the general access has a maximum wall time of 2 weeks, and Condor I think is 90 days. So if you really have a job that needs to run for 60 days, you have to use Condor. Now the thing with Condor and general access is that they usually run on older nodes. So, but if you don't care if it runs on an Intel CPU from 2012, and if you have to wait for a day before to run, then that's the partition for you. If you need to run, because your job is going to run for 60 days, you don't care if it starts in an hour or a day. Now, some groups have purchased resources, and you can use those partitions. For example, if you're in EOES, your department has purchased a large amount of nodes. If you're in engineering, you can use those nodes. Of course, you're sharing with multiple students. So for example, engineering is always busy. There's always running stuff. So then even then, the general access or the backfill might be a good option for you. So I've been talking about sbatch and srun. So how do you submit a job if you're logged into the machine? So there's 2 ways. There's a batch mode. This is called sbatch. Sbatch basically is just you give a package to the mailman and you say just send it, and hopefully it will start soon. This is for non-interactive batch submission. So you really have everything ready. You've everything packed up in this job submission script. And somewhere in the background, there's a job scheduler that takes care of it and makes sure that it runs. And you might get a notification when it stops, when it finishes. Sometimes you want to run something interactive. And for that, you have the program srun. Srun is more interactive. It's basically, you say, start this program, but I want to see it running. And for example, interactive is the same thing. You can, for example, start a batch shell, so you can kind of log in to a compute node. Now, srun is very handy, but if you really want to interactive, then you also have to open OnDemand. But if you want something fast to run, for example, if you have a short R script or a short MATLAB script, srun is perfect for that. Now, there's also a second thing for srun, and I'll talk about it in a second. So sbatch. Sbatch, this as the syntax, you have the sbatch and you give it the script and you give it a number of flags. Those flags are all in the manual of sbatch. So as you can see here, you have the sbatch -p for partition my queue, the -n for number of cores in my script, which requests 10 cores from script. As you've seen before in the job script, this can also be in your script itself. So there's 2 ways of requesting these resources. It's either in your job script or on the command line. Now, which one you want to use is up to you. You can use it in the script, you can program it, you can use it to the command line. But this is Linux, there's no one way, there's 20 different ways. If you just use sbatch my script, it will request 1 core from your default queue, which for most people is general access. And there's a number of flags that you can use, and they're all in the manual. For example, if you start multiple sbatch and you want to have them in different directories, you can specify the -D to specify the folder where you want to start things. So srun. Srun is for more interactive jobs. So if you log into a submit node or login node, then srun will start a new job. And if you use it like this, -p my queue, this is my program, it will start my program. It will sit there and blink. It will say start waiting for job blah blah blah. It will sit there and blink until a compute node is ready, and then it will start that my program in the foreground. So sbatch will just immediately give you a job ID, and then we'll come back with a new prompt. Srun will just sit there and wait until your job runs. Now there's some interesting issues if you use srun-ask, where you ask for multiple cores. Because if you run srun, it will start a number of instances of the script, which can be interesting. For example, if you run an interactive program like MATLAB and you start it multiple times, it really does start multiple MATLABs, and that might not be what you want. Now, if you run it in a script, if you run srun in a script, it will not interpret sbatch flags. So if you create your job submission script, these are all little caveats that you have to be careful. And there's the command salloc, but it's slightly different than srun, and I'm not going to touch on that. It's salloc is a little bit more advanced. It will more or less allocate a node for you, but it will not run anything on it. And you later have to attach something to it. It can be very useful, but if you're just learning to use Slurm, I would just not touch it. Now, there's another way of running srun. This instance is actually, in my case, I think that Slurm should have just renamed this, just given a different name to this. If you used MPI in the past, you probably used something called MPI run. So MPI run, it spawns multiple processes on different nodes or different cores, and then it starts it initializes your parallel program. Slurm came with a replacement for MPI run called srun. And for example, MVA Pitch 2 doesn't even provide MPI run anymore. So if you have a job script with a parallel program, you have to start it with srun, which is kind of confusing. You submit it with sbatch, and then you call srun. So I showed in the example of the parallel program, if you use srun my program, it will start on the number of cores that you requested. Of course, you can also use a smaller one. For example, you can allocate 10 cores and only start a program on 4 cores, which sounds like it doesn't really make sense, but there are cases where that would be useful. Now, of course, you get an error if you ask for more cores than you requested, although there's a way to circumvent that too. So, interactive jobs. I said srun starts a program interactively, but to really be interactive that you can type, you have to allocate. In Linux talk, it's a P2I. It's a terminal. And I think P is physical, but I'm not sure. So to run an interactive program, you have to use srun-P2I and then your program. And program can be bash if you just want to have a shell script on a compute node, or R, or if you just want to start a debugger, if you want to debug your program. For example, the login node has a time limit, it has a memory limit, and if your program needs a lot of memory and you need to debug it, you can debug the program on the compute node directly with srun. This is something that Open OnDemand would also be very useful, because we have the Intel compiler suite and you can use the GUI debugger. Some people prefer to use a GUI program above command line. But this is for the command line debugger. Now, there's a little strange thing here. Slurm is full of little surprises. If you use -nx for srun, it will start a program multiple times, but not if you start it with P2I. And that kind of makes sense, because you can only have one terminal input for one program. You cannot start 10 different programs that all expect to have a terminal attached to it. And srun will start from your submit directory like all the other commands. So I put a little, some of these commands on a little thing. We have a cheat sheet which has a lot more of these commands. So there's the common sbatch, srun, there's sq. sq shows you the jobs in your partition, or it can show you a specific job. You can even ask for the start time of a job. For example, you submit a job and you want to know when does it start. Now, this is always tricky because it's just an approximation. There's an ask cancel. If you submit a job and you think, well, wait a second, I made an error, you can cancel a job and it will not occupy any slots, and your colleagues will be happy with it. And there's an info, and info shows you all kinds of useful things. For example, it shows you the notes in your partition. Now, sorry, Casey, I did not include this, but we also have a command called RCC tool. RCC tool also shows a lot of very useful information about your partition, your account. And I might run it during the demo. So memory is always a tricky issue with Slurm, because Slurm takes memory in consideration, and the default, and this might be old or out of date, I think we already have 4 gig for the backfill. So the default for all our partitions is 4 GB per core, with some exceptions. Now that might not be enough for everyone, so you can request more. So for example, you can ask for memory per CPU or total memory. For example, you have a sequential program that needs, say, 60 GB of RAM. You say srun-mam equals 60 GB. Now the tricky part with Slurm is that Slurm actually doesn't take memory in consideration, but it allocates certain cores. So if the default is 4 GB per core, and you ask for, say, 40 GB, it will allocate 10 cores for you, which more or less comes to the same thing. You'll get your 40 GB. And so I'd say it here, if you do mem equals 5, it will reserve 2 cores. Now that memory limit is enforced. If you ask for 5 and your program starts to go towards the 6 GB, it's not immediate, but it will get killed. And sometimes you get tickets and it said, well, my job got killed for some reason. And it shows there, unfortunately it shows it in bytes, but it shows you X amount of bytes is larger than such and such. That usually means that your job got killed because you used too much memory. And most of the time when you ask for help, we said, well, try to increase the amount of memory. Now, of course, the more memory you ask, the more cores are mapped to your job. So it might take longer for your job to start, because if you ask for 100 GB, that means that you almost have a full node. So one of the questions we are always being asked is, why is my job not running? Well, you might be running in a partition that has limited amount of cores. For example, if your professor only bought 100 cores and your lab mates already are running on 90 cores, then your 20 core job will not fit. Or maybe you ask for too much memory. Slurm doesn't always give good errors. If you ask for memory that's not available, it might just sit there and wait until something becomes available. And it says, well, my job is not running. Well, you ask for 500 GB, which is not there. So there's a number of things you can run to see what's happening. You can use sq to see, and this is a bash command to see your username. So to just only show your jobs. You can show what is all running in your partition. If you're in EOES, you can say sq-p EOSQ, and you might see that some student is monopolizing all the cores. And then you can use scontrol show job with the job ID that you received from sbatch, and kind of you can see a whole list of things for your job. And one of them is, for example, it might be resources not available. So now that you kind of have a feeling of how to run a job, what kind of software do we have? Well, we have a lot of software packages. We have plenty of R, Perl, Python modules. We have all kinds of libraries, netcdf. We have all kinds of compilers. And we have a whole list on this URL, rcc.fsu.edu/software. But in general, if there's something that we don't have, just ask us. We will be happy to install it for you. Most of the cases, it's just compile something and we'll install it for you. Of course, if you really feel adventurous and you know what you're doing, you can compile the source code yourself and compile it in your home directory and then run it. So for example, we have, well, actually this is already out there. We have 4 compilers. We have the GNU compiler, we have the Intel compiler, we have the PGI compiler, we have the C-line compiler, we have Java, we have all this Python, several MATLAB, Stata, R. We have, I think, hundreds of custom packages. So first look on the software list to see if it's there. And if it's not there, we can always compile it for you. There might be cases where it's not possible. Sometimes it needs a standard, a library that's not compatible with our operating system. But in general, we try to install the software for you. Now, you might notice that we have a lot of versions of all kinds of software. For example, OpenMPI, we currently provide, and this is already before our latest update. So we have like a number of levels, like MPI 2, 3, 4, and probably soon 5 for all these compilers. So what we use is a system called module. So if you want to see what modules are available, you can use the command module vil, and you can see a whole list of modules which you can use. So if you want to, for example, use OpenMPI version 4 with the GNU compiler, you say module load GNU OpenMPI and /4.00. If it's the default, you don't have to specify the version. If it's not the default yet, you just specify the version. So for example, if you want to run the GNU OpenMPI for version 2 is GNU-OpenMPI-2.1.0. Now we're going to slowly replace that with a newer system where you first kind of load the compiler itself and then you load like the MPI version. So it kind of, it's a little smarter where it says, oh, if you want GNU 8, then these versions of OpenMPI are available. If you want to load the standard GNU on CentOS is like 5 or so. Then these modules are available. And that's coming soon, but not yet. So I wasn't sure if this had to go in the beginning of my presentation or not. Imagine you don't have an account yet and you want to start with us. So first of all, you need an FSU ID. Everyone who works at FSU, every student at FSU has an FSU ID. That's how you log into Canvas. This is how you log into Omni. If you're a guest, because we have several guests, you need an FSU ID. And that's kind of a hard requirement now. So if you click on sign up as guest, you go to a page that shows you how to apply for an FSU guest ID. That's very easy. It's usually done in a few days or so. You need a faculty sponsor. So you get your FSU ID and you log in here with your FSU ID and your FSU passport. If you already have an RCC account, you do the same thing. If you don't have an account yet, it will give you this form and it will allow you to set up an RCC account. Now, if you're faculty, if you have a faculty appointment, you don't see this because you sponsor yourself and you'll immediately skip this step and your account has already been approved. But if you're a student or a postdoc or staff, you have to select a faculty sponsor. And the reason is because we want to keep it's accountability. Everyone needs to have a sponsor. So your username is your FSU ID. This is just a test account that Casey made for me. You create a password. You can sign up for our newsletter. Our RCC newsletter is a bi-monthly newsletter. There's little articles. It's like workshops are coming. Those things. Mailing list, the notice list. It used to be mandatory to be part of it. Now you can just sign up, but it's very useful to be part of it because if something breaks, if our storage system go down, if there's a thunderstorm and our data center blows away, we send out mailing notices on the system notice list. And finally, we want you to agree to abide by the RCC policies, and it's basically standard FSU policies that don't share your account, don't do crazy stuff. And once you get this, once you commit, you are in the pending approval. So in this case, it shows exactly what you're waiting for. You're waiting for Mr. Casey McLaughlin to approve your account request. And it'll show you your affiliation, what mailing list, and the status of your account. So once this Mr. Casey McLaughlin approves your account, it will be unlocked and you can log in to our systems. You will get an email about that too. So if you ever want to change your sponsor in the future, for example, you move from one lab to the other, you can request a change of sponsorship. You can change your subscription, and everyone will see this. Well, if you already have an account, you don't see pending approval, but everyone will get into this screen. So how do you get access to a partition? So you applied for your account, you start working for this profession. He says, well, I have my own notes. You should get access to it. So what you do, you go to that same page, you log in with your FSU ID, FSU credentials. On the right, on the left, you see this account, groups, and partitions tab. If you click on partitions, it will go to a whole long list of partitions that you're part of and that you're not part of. So in this case, I'm not part of this new professor in engineering, and I want access to it. It's too bad the arrow is in front of it, but it shows you all kinds of information about the partition, like the number of jobs that can run, the amount of processors. So this professor just bought 900 processors. This is the default, this is the maximum. But you want to become part of it, so you click more information. You see the same amount, and you see unigroup and unigroup. Unigroup is, we give access to these partitions through Unix groups. So you click on the unigroup, and it says request enrollment. If you have to make sure that your account name is here, you give a description why you want access to this resource, because this professor will get an email and he will have to say, well, I really don't know this person, or, well, sure. If he has a lab that has only like 3 students, then he might know. But for example, EOES is a very large department, and the person who approves of these requests might not know you. So make sure that you this is just your message to the professor, like, hey, I want to use your system. Please approve it. So you submit a request. That means that the professor gets the request, and once he approves it, within a few hours, you have access to his notes. So what if you need help? We all get stuck sometimes on little things, but the best thing to go is don't email me directly, don't email Casey directly, don't email Alex directly. Send an email to support@rcc.fsu.edu. It's everyone in our group gets these emails from our ticketing system, and if someone is on holiday, then the next person can pick it up. Now try to be as precise as possible. Try to include the path to your script. Try to include things like the output files. Try to tell what error you get. It's nice. It's bad that you get an error, but please try to be precise and tell what kind of error you get. You get a permission denied. You get wrong time of day. Include the error, and if possible, try to include the job ID. It's possible for us to kind of figure out what kind of job ID it was, but if you submit many jobs, sometimes one job might run and one might fail. So try to include job IDs of things that go wrong. So try to be as precise as possible. So I'm not sure if let's try some examples. Now I have to set up the VPN. So bear with me for a second. Are there any questions in the meantime? So that's the Duo app. Isn't it nice? HPC login. So let's stop the share. It's too bad I cannot change the share. And now I'm not sure if this is big enough. So Casey, can you give me feedback if it's big enough on your
Yeah,
screen?
it looks big enough to me.
Okay. So I had to start the VPN, the Cisco VPN, and now I'm logging in. So as you can see, this is all the jobs that are running on the backfill. That's a lot of jobs. And you can see one name. So there's actually, I only see 2 people running on the backfill too, because they kind of really rely on this. Actually, it's only 1 professor. Yeah, we have more users than just 1. So, so I have this one program here that I show everyone. It's a trapezoid. It's a very simple parallel programming. It's just, it determines the integral of a certain function by using trapezoid addition. It's just very simple. MPI init, com rank, com size. It's just what you expect. And then if it loops over your function and it adds up all this little value. It's just a very, so I want to compile this with, say, Intel. So this is just a standard compilation of the program in MPI. And now I always use GNU, but let's just. So what this means, I submit it to the quick test partition, and I use the program trap.sh. It uses 8 cores. The job name is my job name. Now it looks like there's a person called T-Ward running on it. So but my job is not in there, because my job almost immediately ran. And surprise, surprise, number of processors 8. Maybe put it on the top of the screen. Trapezoid, blah, 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 blah. So it ran in 2 seconds. Now imagine that I don't really trust Slurm, so I want to do srun-p quick test. Okay, let's double check. Someone asked about if I have to do the module load. So I have the module Intel OpenMPI, and I have this one in my path. So just srun. Now I start an interactive job on the quick test in the directory that I submitted it from. And as you can see, it kept my path variable, and this one is still in my path. So do I need to run module in my script? No, I don't have to. But it's just for safety, because you might log in the next time you do something with PGI, and you forget to unload it, and you submit a job, and suddenly you're using the wrong compiler. So I always, as a safety, just make sure that your batch script, your job submission script, is standalone and it can run regardless of what your environment variables are on the login node. So I would always advise to just use module load in your script, even though you don't always need to. So now I'm here, and I can just run srun trap, and it runs for me. So this is kind of an interactive parallel job. Now, so I showed this example of the sequential sbatch, where I use the input as a parameter. So here in this case, I do the host name, module load r no save. This uses the input from r input.txt and feeds that to r. So I don't have to type anything. It's almost, for r, it looks like I'm using an interactive session. So if I cat this thing, it's just very simple. It's just assign the variable a the value 2, and then you print 8. It's almost, if you do like this. So it's submitted batch sub this. Of course, it's the test, so it almost immediately finishes. And it's almost as if I ran it interactively, but it ran it on a cluster. So if you have a very large computation, you can just take your R script, put it in here, and then run it on the cluster, go home, and the next day you'll get this answer back. Of course, I can also just, like I said, run R directly. So now actually you don't see it, but I'm running on a compute node. So for example, if I have a MATLAB or an R function that uses GPU, I can request access to the GPU and run it on our GPU. So it's almost, this is kind of interactive running on the cluster. And this is the command line. If you want to have a more graphical interface, you can use Open OnDemand, and next week tune into the presentation next week for the NPR. So
Actually, this Thursday, Paul.
Sorry, Tuesday. Yeah, Thursday.
Thursday. Yeah.
Yeah. Now, if you're a little nerdy, all of these batch scripts start with bash. This is an example why I use Perl. So I have the Perl command line here. I call it the output is going to go to the program to the file called Perl test. I want 2 cores. In this case, it doesn't really matter. And here, instead of bash things, I use a Perl. It's basically a Perl script. So if I just run sbatch, well, surprise. So this might look very silly. This is a very silly example. This can still be very handy. And why would, for example, if you have if your workflow is just not one program, but many programs, and if there is a certain workflow in it, if you have loops, if you run something in a loop, if you run something conditional, if you run a preparation step, and then based on some variable, you run another program, then sometimes you want to do your whole job script in a Python or Perl script. So you can say, well, I can just have a batch script that calls a Perl script, but why not use the Perl in the batch in the job submission script? So this is kind of an esoteric kind of use, but Slurm is very flexible as long as there's nothing in between here. Yeah, you can have an empty line or no empty line, but there cannot be any text. So I think that would be I don't think I've had any good other examples. So I have some slides, but now I have to switch back again. Stop share screen. This is why I wanted to use OBS. So one thing is more an advanced topic that would be handy. Imagine if you have multiple jobs and they all depend on each other. For example, you have one job that does something with your data, and then the next job will do something with that data, and the next job will do something with that data, and it kind of works as a kind of workflow where every little program does something with the data, but they all take around 2 to 3 or 4 hours. So you cannot combine them all in one large batch script. What you can do is you can have job dependencies. So if you have job A that needs to do something with the data, and job B that needs something to do with the output of job A, you can say job B can only start after job A finishes. That's job dependencies in Slurm. Now there are multiple dependencies, but in this case, what I mentioned is called the dependency is after OK. So after OK means just run this job after the other job, this job ID finishes with successfully. So if the other job failed, this job will never run, and it will just hang there in the queue and will just give a dependency error. Now, another type is a singleton dependency, and that basically means imagine you have 20 jobs with the same name, but only one can run at the same time. And then you have this job dependency called singleton, and they all have to need the same name called job name. There's also lots of good examples why someone wants to do that. Sometimes you just want to run it on, if you have one large data set and you have different programs to do all little bit things, but you can only have one running, then this is so there's multiple different dependencies, but most people use after OK or singleton. If you look in the manual of sbatch and you look for dependency, you might see several of them, but these are the most common. Shared MPI space is also more advanced. We've seen this mainly in Earth and atmosphere sciences, where people have 2 different models that work on different parts of the atmosphere. For example, you can have an ocean model and you have an atmosphere model, and they work independently, but they still need to share data between each other because the surface temperature of your ocean might be exchanged with your atmosphere model. what can be, you can program it in one large program, or you can have multiple programs that share an MPI communicator space. This is more advanced MPI, but I don't think we're going to have an MPI workshop this year. So I just mentioned a little bit how you do this in Slurm. If you use MPI communicator space in multiple programs, you can do that in Slurm by having a layout file. In this case, you want to run your program on 16 cores, and the first 8 are used by program 1. And the second program are used by, I take up the top 8 cores. So you can specify 0 to 7 is program 1, 8 to 15 is program 2. Now, if this program starts, you have 8 instances of program 1, you have 8 instances of program 2, and they see each other's MPI space. So program 2, if you look at the MPI rank, they all run from 8 to 15, but they can do exchange messages between 0 and 7, which is program 1. So this is not a lot of people who use that, but this is how you would do that in Slurm. So you'd specify a text file where you lay out which cores are mapped to what program, and you submit it like this, where you have, and 16, it says multiproc, and this is the layout file, and then all the other parameters that you want to use for srun or sbatch. And I think that is all my slides for today. And I went very quick. So if anyone has questions, please. I'll just